Diode laser engravers are the compact machines that are revolutionizing DIY projects, art, and manufacturing. But how do these machines actually work? What makes them so precise and versatile? In today's video, we'll break down how diode laser engravers actually work by exploring how they produce that concentrated laser beam, how the beam cuts and engrave materials, and how motion control system guides the laser to create your design. Let's dive in. Laser, or light amplification by stimulated emission of radiation, is a technology that generates a highly concentrated focused beam of light. A laser beam is a highly concentrated stream of photons, which are tiny particles of light that travel in the same direction, at the same wavelength, and with perfect alignment. This is called coherence, which makes the laser light incredibly focused and precise, unlike regular lights that spread out in all directions. So how is this beam of light generated? At the heart of the laser module is the laser diode, a small but powerful component responsible for producing these photons. When electricity flows through the diode, at the PN junction, electrons and holes are forced into the I layer, where they meet, combine, and release energy as photons. Inside the module, reflective surfaces and lenses enhance the light, making it more concentrated and powerful. A focusing lens near the front of the module takes the amplified light and narrows it into an intense pinpoint beam. This is what makes the laser so precise and effective for cutting or engraving. After understanding how a laser beam is generated, let's break down the essential components of the laser module. The core of the laser head is the laser diode, which produces the beam. Next, we have the laser driver. The driver ensures a stable flow of current and voltage to the diode. Diodes are highly sensitive components, and the right driver prevents damage by regulating power. Next, we have the heatsink and the cooling system. To prevent overheating, the core module is often paired with an additional heatsink and cooling fans. These cooling fans help maintain optimal temperatures, extending the diode's lifespan and enhancing performance. Next, we have the focusing mechanism. A lens system is installed to focus the laser beam for precision. Two common types of lenses are used. We have the 3-element lenses with long focal range between 2 and 10 centimeters, suitable for engraving, and the G2 lenses of short focal lengths ranging between 2 and 10 millimeters, offering higher efficiency for cutting. Lastly, we have the laser module housing. The entire laser head assembly is enclosed in a protective housing. The housing protects the internal component and ensures safety by shielding the laser from accidental exposure. It may also serve as a mounting point for the laser module. Laser engraving is a process that permanently alters the surface of a material. When the laser beams strike the surface of a material, it delivers an intense, highly focused burst of energy. This energy is absorbed into the material at the precise point where the laser is focused. When the laser beam hits the surface, the temperature at the point of contact quickly rises beyond the material's sublimation point. The material instantly vaporizes, transforming directly into gas, leaving no liquid residue behind. This vaporization removes the material from the surface, creating a precise, clean engraving or cut. The material's response to this high energy depends on its properties such as color, reflectivity, and thermal conductivity. Darker materials absorb energy more efficiently, making them easier to engrave on. Reflective and transparent surfaces may require additional coating or higher laser power. As the laser continues its work, it carves the material into the desired shape or design. The depth of engraving or cutting depends on several factors, like the laser power. Since higher power results in deeper cuts or faster sublimation, the beam speed. Since slower speed allows for more energy to transfer into the material, creating deeper marks or cuts. And the material type, since each material reacts differently to sublimation, with some vaporizing faster than others. At the heart of any modern laser engraver is a numerical control, a system that allows a computer to dictate the precise movement and actions of the laser. But how does your computer convert a design file into the perfect engraving or cut? The process begins with a digital design. Next is converting these design files into G-codes. The laser engraver doesn't understand design files directly. These files must be first translated into G-code, a language that machines understand. This happens through a computer-aided manufacturing software like Laser GRBL, Lightburn, or others. For vector files, the software traces the path of the design, converting each line or curve into a series of commands for movement. For raster files, the software interprets the image as a grid of pixels. Each pixel is assigned a value corresponding to the laser's intensity. For example, darker areas get higher power while lighter areas get lower power. The output is a G code, a list of instructions that tells the laser engraver what to do step by step. Now the next step is sending the G code to the laser engraver. Once the G code is generated, the computer sends it to the laser engraver via USB connection, Wi-Fi, or an SD card. Here's how the commands work. The G code specifies the X and Y axis precisely to position the laser head above the material. The G code controls the power output of the laser diode, determining whether the laser is engraving or cutting. The G code also dictates the speed of the laser head's movement and the duration the beam stays in one place. The laser engraver's microcontroller reads the G code commands line by line and translates them into action. The process is repeated line by line or pixel by pixel until the entire design is completed. The frame of the laser engraver plays a crucial role in ensuring precision, stability, durability, and safety during operation. It is the foundation on which the entire machine is built, and a well-designed frame directly impacts the quality of the engraving or cutting process. The frame of the laser engraver serves as both the physical structure and the guiding system for the laser head and work platform. The frames are typically constructed from aluminum, which is lightweight yet strong. The versatility of diode laser engravers spans numerous industries, including manufacturing, personal customization, art, and education. From engraving intricate designs on wood to cutting metal components and crafting high-quality prototypes, diode laser engravers offer precision, efficiency, and a broad range of possibilities that make them an indispensable tool in various fields, whether for personal projects or industrial application. These machines empower users to produce customized, detailed, and professional results with ease. If you found this breakdown helpful, give this video a like and subscribe to the channel for more breakdown videos like this.